Welcome. Today, we're going to talk about the one simple concept that gives AI its power. We're looking at the fundamental spark that lets a machine think in curves, not just straight lines, which, as you'll see, is the real secret to understanding our messy, complex world.
So let's just start with a puzzle. Our world is filled with curves, right? The arc of a smile, the shape of a sound wave, even the path of a ball you throw. But a computer, even a super powerful one, really struggles with that. Why is that?
Well, that right there is the heart of the problem. A computer's natural state, its entire world, is linear. It's all built from straight lines, and without a very specific trick to break free, it's totally trapped by that.
Okay, so let's really dig into this. This limitation has a name. We call it the linearity trap.
You see, a neural network, the brain of an AI, is nothing more than a linear model if it's missing its secret ingredient. You can just think of it as a really, really fancy calculator that can only draw straight lines through data. That's it.
Now, this is where it gets really wild. You could build an AI with 100, maybe even 1,000 layers. But if they're all linear, the math just collapses them all down into one single, simple layer. It's like having 100 rulers stacked on top of each other. It doesn't actually make you any better at measuring things.
So, what does this mean in practice? Well, a purely linear model might be able to spot a simple trend, sure, but it could never, ever understand the complex, curvy patterns of our world. Things like the shape of a smile, or all the subtle nuances in how we talk.
So, if the straight line is the trap, how in the world do we get out of it? It's actually pretty simple. We just need to find a way to bend the line.
And this is the solution. It's this tiny piece of code called an activation function. We stick one of these after every single calculation the network makes, and its only job is to introduce a little bend or a kink into the data. That's what gives the network the power to learn shapes. It's the spark that lets it truly learn.
Now, there are a bunch of these line-bending tools out there, but for the rest of this explainer, we're just going to focus on the undisputed king of them all. It's called ReLU, which is short for Rectified Linear Unit. And you know what? Its incredible power comes from its almost absurd simplicity.
I mean, look at that. That's the whole thing. All it does is look at a number, and if that number is negative, it just turns it into zero. That's it. And you have to believe it. This one simple idea is what powers technologies as mind-bendingly complex as ChatGPT.
So let's just see it in action here. If a neuron sends a signal of -2, ReLU just blocks it, turns it to 0. If the signal is 0, well, it stays 0. But if the signal is +2, ReLU just lets it pass right on through totally unchanged. It's basically a simple one-way valve for information. And because it's so simple, it is blazing fast for a computer to calculate. That speed, plus the fact that it solves some other tricky math problems for the network, is exactly why it's the go-to, the default choice for over 95% of AI engineers building the guts of a neural network today. Of course, ReLU isn't the only tool in the box. For more specialized jobs, you've got others. There's Sigmoid, which acts like a dimmer switch, squishing any number into a value between 0 and 1. That's perfect for a yes or no answer. And then there's TAN, which is kind of like a taller dimmer switch, squishing values between -1 and 1. Okay, so the network has used thousands, maybe millions of these little ReLU bends to think about a problem in this super complex, nonlinear way. But at the very end of it all, how does it actually make the final call?
This is it, the final crucial step. The network has all this abstract thinking floating around, but we need a concrete answer. We need it to commit. We need it to tell us, is this picture a cat, a dog, or a bird?
And for this last step, the AI uses a very special function called softmax. You can think of it as a probability distributor. It takes the network's final, raw, kind of messy thoughts and cleans them up into clear percentages that we can actually understand.
So let's imagine that after all its calculations, the network's raw scores, we call these logits, they really strongly favor cat with a score of 2. It has some confidence in dog with a score of 1, and almost no confidence in bird with a score of 0.1.
Softmax just takes those messy scores and converts them into these clean, simple percentages that, and this is key, always add up to 100%. So now, as you can see here, the AI can confidently say, yep, I am 70% sure this is a cat.
All right, let's bring this all home. What's the big takeaway here? Why does any of this really matter?
The most crucial point is this, that one simple trick, the ability to bend the line, repeated millions of times by functions like ReLU, is what separates a simple calculator from a powerful AI. It's the spark that allows pure mathematics to learn the beautiful, messy, curvy patterns of our reality.
And that's what's so amazing to me. An idea as simple as just turn the negative numbers into zero is a foundational pillar of all of modern AI. It just proves that sometimes the most revolutionary ideas are the simplest ones. And that kind of makes you wonder, what other simple ideas are out there waiting to shape our future? Thanks so much for watching.